Hello my dear students, welcome to KCET Masterstroke. The session is today for integrals, one of the highest weighted chapter for your KCET, right? So you know the importance of this chapter, the questions coming from it, right? So we'll learn again everything in the in brief. Of course, the chapter is very big, we can't go in that detail, bacha. I have done in KCET around 8 to 7 lectures in this chapter. So you can go ahead if you want to invest more time into it, please go ahead, check the playlist out and learn every concept in detail, solve questions on every concept in detail, bacha, from the playlist. Okay, in the session today I've taken almost 7 questions which is going to be based upon different varieties of questions, varieties of topics which is there, for example by parts, partial fractions. Okay, then there is a particular function. So all type of questions I've taken to not let you be confused about any particular concept. Okay, I have taken the question to create the bridge between the concept and the problems, so that's going to be certainly helpful. So let's quickly dive in the chapter and learn the first concept to solve the question number 1 in this particular session of KCET Masterstroke for integrals. Okay, so what we have here is integration of some standard functions. Simple formulas I've just kept. Okay, just you're gonna keep using in all the questions, like very basic fundamental formulas. You can go through it. I can give you one brief of all of this as well, because not much is there over here. Integration of a constant 1 will come as the variable of the integration x. Okay, a will be again kept as outside the constant, again x will come, so ax plus c. For that x power n will, what will happen? The power will be increased by 1 divided by the same power n plus 1. Okay, this c is always constant, it's called as the constant of integration, always will be there in the case of indefinite integral. Yes, we'll also learn, bacha, definite integral, their properties. That's very important, right? So please check, we have for sec sine, cos, sec square, cosec square, sec tan x. Okay, so all the formulas are over here listed, bacha. 1 by x is ln x, e power x remains e power x, a power x is nothing but a power x divided by ln a. So all the formulas are listed over here. You can have a look at it. How, sir? Please go ahead and join the WhatsApp channel if you have already joined. Very good. I know I keep repeating it because very important. All sessions PDF will be given in the WhatsApp channel only, so you have to join, you must join. Please, if you're following me, join the WhatsApp channel, which is absolutely free. Join it today, okay, and get the sessions PDF there. Now if you want, I have one very introduction, very important announcement to make for all of you regarding our the launch of KCET test series. We have launched it, sir. What is there in the test series right now? We have given you a free trial, actually. Very unique thing. You'll not find it available any place. Okay. First of all, Deeksha is here and helping you out on the KCET for a very long time. Please go ahead and check our records. Okay. We have produced very good rank. We have helped a lot of students to get a very good rank in their whatever they have planned in career, whatever their goal was, we have done better than that, right? You can go ahead and ask them. Okay, so we are here to help you out as well. What you can do is take this test series. I'm not asking you to take it right away. What you do is please take the free trial version right now. We have given you 4-part test for free, sir. Yes, 1 physics, 1 chemistry, 1 biology and 1 mathematics. Test will be free. Each paper will have 60 questions as per standards. You can solve it. We have given you question papers, PDF solutions. We have also given you video solutions for free. Okay, yes, you can register. You don't have to do anything, just register with amount of 0 rupees and get these sessions free. Try out yourself. If you feel yes it is worth it, sir, please go ahead and purchase the entire test series, which will have 31 more tests. Okay, again that will be coming in the paid versions, which will be open, bacha, full syllabus and chapter wise tests. Okay, you'll have chapter wise and full syllabus as well. Detailed video solutions will also be given with the analysis, and you'll have chapter wise one-shot revision videos, chapter wise insights for last 5 years for KCET papers. So all of this is included, bacha, in your test series, and that can be available right now, only right now at 14.99. If you purchase this amount, you can get the PU2 Success Blueprint test series for only ₹1. This is again a launch offer just going on right now. As we keep moving towards our examination, what will happen now? More students will join in, and for that reason we'll have to maintain a bigger team to maintain all these things. So the prices might go up, the cost might increase. As simple, no demand and no supply. So for that reason, this is the offer price. Please go ahead and purchase it right away, 1499. Okay, even though the first paid test bacha will be live from 17th of March, you can purchase right away. Okay, please let me know if you have any queries, any your concerns regarding the test series. We'll try to resolve it right away. Okay, let's move on to, sir, the chapter Masterstroke for integration. So first thing, sir, let's come back to the knowledge of for a few things. If there's a derivative given here, if you integrate that, to remember, basically integration is what, sir? It is a reverse or whatever you learned, alternative, just alter the differentiation, you get the get the integral, right? So if we have derivative given over here, check this out. If we have, sir, derivative given over here, if you integrate that, no, you'll get the function itself. Means you differentiate the function to reach f dash of x, right? So what you do is integrate this part to reach back to the function. You'll have a constant, of course, because of bacha, the nature of the integral. What is that? Indefinite integral. So you'll have a constant obviously involved there. Okay. If let's say you have a plus minus sign, you can separate the integral to two different terms. So you can integrate the first term as it is, then add or subtract to the second term's integration. Is that clear? Okay. Again, bacha, if you have a constant to multiply to the function, you can take it out as well and then integrate. Okay, and then if you have f and g are two functions defined like this, what you can do is, let's say I'm saying that integral of two different functions. If I have integral of fx and integral of gx equal, it means bacha, the function has to be unique. Function has to be equivalent. Sorry, not unique, equivalent actually. I went ulta. They have to be equivalent. Forgive me for that. Let's move on to next thing in this. First question, sir. First question based upon your very simple formula that you've learned. Yes, sir. What is integration of sec square? It's tan. Yes. Is it over? Answer is going to be how much, sir? Let me know. Sec square of 7 minus 4x. So tan square of 7 minus 4x. Great. Is it over, bacha? No, sir. Of course not. Divided by minus 4 and plus c will come, na, sir? Yes, bacha. So my answer would be minus 1 by 4 tan square 7 minus 4x plus c. Please check. What is the answer? Option A is looking correct. Option A is correct, sir. Right? This is the 7x minus 4. That's why it is wrong. This is 7 minus 4x, no? So option A is correct for question number 1. So first question was based upon the simple formulas for standard functions which was there, which I listed in the first slide itself. With the help of that, we can solve this question. Let's move on to the next part. Methods of integration, MOI. We have 3 methods, but the most important method, bacha, will be your method number 1, by substitution. Why it's important, bacha? Because throughout your calculus, no, substitution keeps coming back and forth. Okay, you'll have in differentiation, you'll have in even in limits, you'll have bacha this in different integral also, so it will keep coming back to you. Okay, that's why substitution is very important, very important. It makes our calculation easier, our whole problem easier. Okay, so you'll see that. Okay, of course. So that is there. Second bacha is integration using partial fractions. We use that, right? We create partial fractions with the constants a and b and c like that. We'll show you that as well. And last one is by parts. By parts. Okay, so we have 3 methods over here. We'll learn all the 3, but again the first is the most important method. I'm being partial over here, but yes, first is the most important method out of all the method of integration. By parts is there, but even that is very simple. Okay, but substitution, no, it is not a unique formula. There's not formula approach. You have to look for what? You have to look for derivative in the function. If you can find for any function fx, okay, if you can find derivative present in the function, then only you'll try to substitute it, right? For different question there will be a different approach. That's why I'm saying that it's very important. You need to practice a lot of questions in the substitution. If you are struggling, if you're somebody, let's say if you're somebody who's struggling in this particular topic, integration by substitution, but you have to solve a lot of questions in that. There's no other way out. Okay, I'm sorry for that. You have to go ahead, check my playlist and learn and watch the video on this part, integration by substitution. I've done one session on that. Please go ahead and check it out. Okay, next what we have a look. Substitution method, bacha, we have some standard substitution as well. We have some standard substitution. What are those? If I have, let's say, given in this format, you simply take ax plus b as t. Okay, it'll make this whole thing to be f of t, right? F of t. And then what you have to do, sir? Differentiate. If you differentiate, you're going to get a, so equals to dt by dx. So what are you going to get? Dx as, dx will be equal to dt by a. So you'll replace, bacha, this as, this will become integration of f of t dt and 1 by a will come. This is easier, right? This is easier to do it. At times it will be. Over here you can't see because of the function is not given here, but at times it becomes easier to integrate. Okay, so that is why we can substitute over here. If let's say I have a derivative for this function phi x, I have a derivative present over here. What are you going to do? Simply take the phi x as the substitution. Okay, over here, bacha, I have fx over here, f dash of x over here. Again, derivative is present, bacha. Then what you can do? Simply take fx as the t. So try to look for derivative over here in the case of substitution method. I hope this makes our standing clear. Same thing over here, sir. Take fx as t since the derivative is present over here. Makes our life easier. You'll see in the questions. Okay. Please check what we have over here next. So I have taken some more standard notations for substitution. Whenever you have these type of forms in the functions, okay, whenever you have a square minus x square, so use sine theta and cos theta. Why, bacha? This formula will hold true. 1 minus sine square na will become cos square, and vice versa. It will become 1 minus cos square also will become sine square. So please make use of that. That's why whenever you have this type of form available in the integration, try to use x as a sine theta and a cos theta if it is not easily integratable. Is that okay? Next we have a plus x square or ax plus x square outside the bracket. What are you going to do? Simply take a tan theta or a cot theta. The formula will be used over here is 1 plus tan square equals to sec square. 1 plus tan square is sec square. Okay. Same if I have x square minus a square, what are we going to use? A sec theta or a cosec theta. Okay. So we have given you all the different forms. 1, 2, 3, 4, 5, 6 forms is given, and respective substitution is also given over here. A cos 2 theta for this type of condition. Okay. Here, bacha, you'll have a sin square theta, cos square theta, and you have, sir, a tan square theta, cot square theta. So what you can do is simply download this sessions PDF from the WhatsApp channel and go through this and remember this. Whenever you have this type of functions to solve in integration, anywhere actually, look for this type of substitution. Please go ahead, learn it from here. Okay. Remember this, bacha. Now we have a question like this. Let's solve it. So what we have, integral of e power x 1 plus x sine x e power x. How do you solve it, bacha? How do you solve this question? Okay. So let's do it. Let us do it, sir. Integral of e power x 1 plus x I have divided by sine x e power x. We have dx as well. First thing I taught you is look for derivative. Look for a function whose derivative is present there. I'll repeat myself. Look for a function whose derivative is present in the given expression of integration. If you can find that, that is your actually substitution. Okay. So I can see here, if I take x e power x as my function, I'll have something. Let's take it out. I take x e power x as my substitution as t. Let's try find the derivative of this. It'll become what? It'll become x will become 1. I'll have 1 times of e power x. What I'm using, sir? Product rule. Plus keep x as it is. What I'll have, sir? E power x derivative is simply e power x only. No, I've kept x as it is. Differentiation of ex is ex only. What I'm gonna get on the right hand side? dt by dx. Okay. Sometimes we keep dx on this side also. That's not a problem. Sometimes no. What will happen? Faculties might not write in this format. They'll write dx over here. Same thing they mean. Okay. I'll show you. So take bacha e power x common here. We're gonna get 1 plus x and write dx on this side. Okay. So what I'm getting, e power x. It's not e into x. It is e power x. I can avoid that confusion by rewriting it. Okay. E power x times of 1 plus x dx. We have the same thing over here. Please check. E power x 1 plus x dx. So this whole thing will transform into, check this out, dt. This whole thing will become dt divided by sine t. Isn't this an easier question now? Isn't this an easier question? Of course, sir. So I can write this as cosec t dt, bacha. Cosec t dt. Okay. 1 by sine will become cosec. No. Now this has a formula. Simple formula. What is that? Log of cosec t minus cot t plus c. From here you can write directly the answer as, bacha, this b. If you know it, very good. If you don't know, don't worry, I'll solve the next steps as well. I'll solve the next steps. But here only you can get the answer directly over here as log of tan t by 2. Log of tan t by 2. So this will transform into log of tan t by 2 plus c. What is t, sir? T is x e x. That's why I've written here option is B. Please check. But I will solve it for you. How it's coming, I'll show you. Don't worry if you're having this doubt as well. My job is to take your doubts away. Cosec t minus cot t, sir. How can we integrate this, bacha? How can we simplify this, bacha? It'll become 1 by sine t minus cos t by sin t. Okay, so I'll end up with log of sin t in the denominator, 1 minus cos t. I have the formula right for this numerator and denominator. Individual formulas are there. Half angle formula, it'll become bacha 2 sin square t by 2, half angle formula. Okay, and what about this bacha? This will become 2 sin t by 2 into cos t by 2. Chaliye. So what I have, 2 and 2 is cancelled, sin t by 2, and one of the sign is cancelled over here. What I'm getting now, I have only one sin left in the numerator and cos here, sin by cos na. So tan t by 2. What is t value bacha? T value was, if you remember, it was x e power x. So that's what is written over here. Log of tan x e power x, log of tan x e power x by 2. Clear, right? Okay, this is all right, not a problem. Okay, let me move on bacha to next part. Next, so yes, I'm very sorry, but we have to be precise bacha over here. We can't take too much time doing the chapters because you also have less time. You have a lot of things to prepare, not only mathematics. You can't sit back and study this integration for 8 hours, 9 hours. You have to quickly learn and revise the concept and go back to solving the problems. Okay, so again we will be coming with the problem session, but today let's keep it precise and short for only concepts. Okay, so what else we have? Particular functions. So you have to remember these formulas. I know you have to, because you want to score good marks. That's why you're here. Don't worry, you've already learned these formulas. Okay, just if you go through it, no, you will be able to recall all the formulas. Not difficult at all. Let's see what we have. First one, sir, whenever this is the given, what I taught you, x minus a is there, so x minus a will come in numerator and x plus a will come in denominator. So 1 by 2a log of x minus a upon x plus a. When I have a minus x, this will come in denominator, and 1 by 2a, that rest of the thing will remain same. Okay, when I have plus, looks like a form of tan inverse, so 1 by a tan inverse of x by a. Yes, when I have this log of x plus x square minus a square. So when I have this x square minus a square, what will happen? You'll have log of x plus root of x square minus a square. Same root will repeat. Okay, same root will repeat. Same case, if you have this, it looks like this form, no? 1 minus x square, so it will be bacha simply sin inverse will come. Sin inverse of x by a, this is not going to be 1 by a over here. Okay, next over what we have, 1 upon a square plus x square, you'll have bacha same result like this. This and this is very similar. Okay, log of x, same root will repeat over here. Okay, what about this? This is again a particular function. Okay, whenever you are dealing with numerator, x by 2, same root will repeat, half, and you'll have plus a square by 2 sin inverse of x by a. Please check, same root will repeat over here. Excuse me, a square by 2 sin inverse of x by a. All right, have a look, sir. That's clear. Let's move on to again, few forms are there. This is there in NCERT also, important for your boards as well, but this is there in your KCET as well. What you have, 1 upon ax square plus bx plus c, and in this type of forms which is there. Simple, sir, don't do anything, just make perfect square over here. Try to make the perfect square. Only thing is making perfect square. Which what formula, sir? With this formula, a plus b the whole square, or a minus b the whole square. Try to make that use of these formulas, and then once you get the whole square terms, no, use the suitable form of particular function, whether it's coming in this format, then you will use the respective formula on the right hand side. So very simple. Actually very simple. You've learned this method, no, in grade I think 10 only. You've learned perfect square method. Same thing is applicable over here, not difficult at all. But next one, you'll have to put some effort. Whenever you have a linear term given in the numerator and a quadratic term given in the denominator, whether with the root or without the root, approach remains same. Okay, if you have a with the root part, you'll have a different particular function to use. Okay, you have a without root, you have to use a different particular function. Okay, but over here the approach will be same. What is that? So write px plus q equals to derivative of this bacha. You write px plus q equal to derivative of ax square plus bx plus c and plus p. So first of all, from here only you compare and find. Actually, yeah, I forgot to write here a. So compare and find the value of a and b from here only. After that, replace the whole numerator by this term a and b, this whole thing. Replace the numerator by this whole thing. Don't worry, I've taken a question like that. I'll explain it to you right now. Right now I'll explain it to you, but understand over here, px plus q equals to a times of derivative of the denominator plus b. Compare the constant and the variable term to get the value of a and b, okay, from here only, and then use this RHS part instead of this numerator and use what? A suitable integration form. Okay, so please check, this is clear, right? Okay, same question I've taken over here. Check this, quadratic over here, and we have numerator as linear term. How can you solve it? How can you solve it, sir? So simple, bacha, as I said, take this 7x plus 3 equals to a times of derivative of 3 plus 2x minus x square plus b. Agreed? What I'm getting over here? 7x plus 3 equals to a times, what I have, bacha? This will become 0, right? It will become 2, it will become minus 2x. Correct, na? Right. 0, sir. 2x will be 2, bacha. X square will become 2x with a minus sign, which is there. Okay. Do one thing, put x as 0. Not 0. Put x as 1, sir. It will become 7 plus 3, the LHS part. Okay. And this will be, bacha, a times of 0. 2 minus 2 will be 0, no? Plus b. So I'll end up with a value of b as 10. Value of b as 10. Okay. What next? What next? What I can do is simply compare the x coefficients. So I have over here is 7x, and over here what I have, bacha, minus 2ax. So compare the x coefficient, what I'm going to get? 7 equals to minus 2a. So a equals to minus 7 by 2. Now a I know, and as well as b as well I know. Okay, so a and b are both known, so I can transform this whole thing. As I said, this integration 7x plus 3 divided by root of, what is that? 3 plus 2x, 3 plus 2x minus x square will become so minus 7 by 2. What I'll have over here, integration of 2 minus 2x, no, excuse me, 2 minus 2x, sir, right? 2 minus 2x divided by this whole root, okay? 3 plus 2x minus x square dx will come plus 10 times of same thing, repeat, bacha, integration of 1 upon what I have, 3 plus 2x minus x square dx, sir. 10 times of 1 upon 3 plus 2x minus x square dx. Okay, this is clear, not a problem at all. Okay, have a look. What I've done over here is very, very simple. I told you, no, write this form. I replace this, no, a times of d by dx. A times of, this is a, right? D, differentiation by the whole thing. For the denominator will remain as it is, no? This will remain as it is, bacha. Okay, over here only b is there, so plus b divided by the function. So this is the change for the numerator part. Okay, replace the 7x plus 3 by this numerator. All right, now we'll continue from here. So I have minus 7 by 2. Let's do one thing. We can do substitution over here, bacha. I'm using the substitution. Please check. I'll show you. I'm taking this 3 plus 2x minus x square as t. So I'll get, bacha, this side as 2 minus 2x dx equals to dt, right? So I can write this as dt upon root t. Agreed? Dt upon root t. This is dt, right? And this will be root t plus what I have, plus 10 times of, I have to make, bacha, a perfect square. So it will become, so 1 upon dx. Let's have a look. 3 plus, you take, so over here, take minus sign common. Take minus sign common to make this in one of the forms. Take minus sign common, so from the last two terms. So I'll have over here as minus 2x, or I can write x square first. I can write x square first. 1 second. X square first minus 2x. What is missing? I have a square minus 2ab. What is missing, sir? B square is missing. So plus 1 square minus 1 square. Close the bracket. Okay, this is the root. What I'm getting over here is simply minus 7 by 2. Okay, integrate this, which will become t power 1 by 2 divided by 1 by 2. Correct, now? What is right now over here? This is going to be t power minus 1 by 2. No, integrate this. plus 1 by minus 1 by 2 plus 1. Same thing, no? T power 1 by 2 by 1 by 2. Okay. So this will be 10 only. I'll have over here dx upon, have a look, 3, and I'm going to take this out, bacha. It'll become 4 minus x minus, or x, yeah, x minus 1 the whole square. X minus 1 the whole square, not plus, minus 1 the whole square. I'll show you why. Have a look. So this will be x minus 1 the whole square, and this minus 1 will come outside. It'll become plus 4 now because of this minus sign. So minus become plus. So 3 plus 1 will be plus 4. Okay, that's why I have written plus 4. So my answer is coming. This is cancelled. 2 and 2. I'm getting here minus 7 t power 1 by 2 means simply root. Okay, plus 10 is there. I'm getting here a square minus x square. No, what is this, sir? In the root, of course. This is bacha nothing but dx upon root of 2 square minus x minus 1 the whole square. There's a formula for this. Minus 7. What is t, bacha? T is going to be this root, no? So write the same root over here. This t is going to be 3 plus 2x minus x square plus 10. This constant 10 as it is. Sine inverse of x minus a, or x minus 1 by a. Of course, plus c is there. Sine inverse of x by a. What is x over here? X minus a is x. And what is a over here? 2 square. No, so that's why 2. This is your answer. Please check. This is your answer. 7 minus 7. Okay. That root 10 sine inverse of x minus 1 by 2. Option is option number D. Option number D. Please check. 10 sine inverse of x minus 1 by 2 plus c and minus 7, 3 times of this thing. Correct, no? Option D is correct. Please have a look. I have used this formula, sir. I use this formula, sir. This one. Please check. Okay? I have used that over here. This part. Clear, no? Let's move on to next thing. This is clear. Okay. So what we have, so next part is partial fractions. So whenever, same thing we used over here somewhat, right, no? By distributing it. We will not say exactly, but yeah, that's what we have used somewhat, making this whole thing into different fractions. First fraction here, second fraction there, over here. Same concept we have, but just similar concept we have in case of partial fractions. Whenever the function is written in this format, no, we had this kind of function right now. We wrote it like this: a by x minus a and b by x minus b. Okay. There we had a differentiation, of course, but we'll not consider it over here. If you have two factors over here or two square variables, okay, you're gonna take two different constants, a by the first factor, b by the second factor. Okay. If you have three factors, which are gonna take three variables, a plus b plus c, again the three different factors. If you can't factorize it, you can factorize over here, but that is okay. If you can't factorize, you can take it like this also: bx plus c by x square plus bx plus c. If this cannot be factorized, you can simply write like this: bx plus c by x square plus bx plus c. Okay, so I've given you a list of all the type of proper in rational functions and their type of partial fractions. How you take that, please check. Okay, so download this session's PDF and make use of it. Again, a very good question upon this particular topic. I know I'm not giving you much time in that concept part. Not much is there, but actually not much is there, sir. Okay, applying the concept is very, very important. So I've taken this form. Okay, I've taken this form, sir. First one, please check: 2 cos x upon 1 minus sin x, 1 plus sin square x. This question is actually using substitution also. As I said, substitution makes our life simpler. That's why it's very, very important. Have a look. What substitution, bacha? Substitution is over here. Very simple. Very, very simple. Have a look. What substitution, bacha? Substitution is, sir, sin x equals to t. Differentiate it now. Cos x equals to dt by dx. So I have cos x dx equals to dt. Okay, substitute it back in the given integration. So I will become 2 can be kept outside. Okay, dt upon 1 minus t and 1 plus t square. Okay, now let's look at one very interesting thing I'm going to do over here. So it'll become like this: integration of 1 upon 1 minus t plus 1 plus t upon 1 plus t square. That is it. Check this out. How? Check this out. If you take LCM, so what will happen? 1 plus t square will go over here. I'll have 1 plus t square over here, and over here what I'll have? Plus 1 plus t is already there. This multiplied with 1 minus t. Correct, now what I'm going to get? 1 minus t square. So that will cancel with t square, and 1 plus 1 will become 2. That's what 2 is over here. So I'm actually making a fraction over here with the help of this. How will you get to know? By practicing, of course. Okay, so let's look for something that will help me out to get the same numerator. Okay, so 1 minus t square is on this side, 1 minus t square over here, and I have 1 plus t square. This will be cancelled. I'm ending up with 1 plus 1, which is 2. So I don't have to write this part, I'm just explaining you. Okay, surely I'm going to erase this part over here. This part looks messy kind of. Alright, sir, please have a look. Now my all work is very simple. Just simply, I've taken one mistake over here. I've done one very big mistake. I've taken here as dx. It will be dt, it'll be dt, sir, actually. Excuse me. Okay, what we can do is separate this. For this also, this plus sign, it will become 1 plus t square, 1 upon 1 plus t square, and t upon 1 plus t square. Okay, so this whole thing will transform it like this. Integration of 1 upon 1 minus t with the dt, of course. You will have again, bacha, 1 upon 1 plus t square integral with dt, of course, and then bacha plus t upon 1 plus t square with dt, of course. Okay. Now let's check. So for this part, it's simply going to be log of 1 minus t divided by minus 1. Correct, na? T is negative, that's why minus 1. Okay, what about this, bacha? Tan inverse of t. This formula 1 plus t square is simply going to be tan inverse of t. What about this, sir? This is very important. This part is different. Have a look. Take here 1 plus, for this part separately, 1 plus t square equals to, take as, let's say, p. What I'm going to get? 2t dt equals to dp. So this will become, sir, t dt is dp by 2. Okay, this will become integration of dp. 1 by 2 is outside over here, 1 and this p. Correct, now 1 by 2 dp by p. Okay, so let me continue with this step. This is as it is, no? Minus log 1 minus t, that is it, plus tan inverse of t. Okay, this will be again plus sign. I'm getting over here is this as, please check what I'm getting, sir. Minus log 1 minus t plus tan inverse of t plus 1 by 2 log of p. We'll keep back the variables. Okay, so this will be, please have a look, this will become, so p is nothing but 1 plus t square, no? It will become 1 plus t square, no? Log of 1 plus t square, sir. Okay, so let me write it over here. I'll get minus log 1 minus t, okay, 1 minus t plus tan inverse of t, okay, and I'll have plus 1 by 2 log of 1 plus t square. Put back the value of t as sin x, you'll get the final answer. I'll write it over here for all of you. Okay, this will be coming as minus, I can write it over here, minus log 1 minus t, no? So 1 minus sin x. Okay, this is close, bacha, bracket is closed, 1 minus sin x. Okay, next, sir, tan inverse of sin x, tan inverse of sin x, correct, no? T is sin x, right? So tan inverse of sin x. What else, bacha, I have? Plus 1 by 2 log 1 plus sin square x. I can still simplify this with the help of property of logarithm, but not important. Okay, this is more than enough. This is more than enough for your answer. Please check. Have a look. Log of 1 minus sin x plus tan inverse of sin x plus half log 1 plus sin square x. Have a look. This is done. Okay, right? Let me know if you have a doubt in this question number 4. I'll show you again. Then we'll move on to the next topic. Okay, chali. Now, sir, we have next important part, which is by parts, integral by parts. Means how can we solve this question whenever we have two functions multiplied to each other like this. Fx into gx is given. So what we do is, no, we use preference order actually. I let, what is it, sir? Inverse trigonometric, I is what, sir? ITF. First preference given to ITF. L is, sir, logs, of course, logarithmic function. A is, sir, algebraic function. And T is a trigonometric function. T is trigonometric function. And E is exponential function. Okay, so for all these functions, the order is first to last. From left is highest order, right is the least order. Okay, this is the least order, this is the highest order. Clear now? Okay, so based upon that, we're going to consider, let's say I'm considering over here is, this is bacha, my first function, this is my first function, and this will become my second function. Okay, what you do is, keep the first function as it is, integrate the second function, second in after this put a negative sign, differentiate the first function, integrate the second function, their product, and then integrate again. I'll repeat, differentiate the first function, integrate the second function, their product you take, and then again you integrate. Again you integrate. Is that clear? This is the definition by parts. That's how you use whenever the function is given in the product to you and you have to solve for integration. Okay, please check. Again we have a question like that. See, one concept question like that we'll solving. Again, good questions, right? All of you will agree with me. E power sin x sin 2x dx. How can you solve it, bacha? This is going to be very simple. E power sin x sin 2x will become, sir, 2 sin x cos x dx as it is. Substitution will come, right? What is that going to be, sir? Sin x equals to t, differentiate now. So cos x dx equals to dt. Hana? Let's use it now. What I'm getting, e power t, 2 is a constant, right? Keep it outside, times t, and this will become simply dt. Now I'll have by parts. Okay, I let is the preference order. I let last is the exponential function. Last is exponential function. So keep this as function number 1, this function number 2. What is the answer going to be? 2 outside, of course. 2 outside, of course. Keep the first function as it is. So e power t will be kept as it is. Okay, sorry. Excuse me, sir. I have made a big blunder, sir. Okay, e power t will be integrated. No, t will be kept as it is. Integrate this e power t, of course. Integrating e power t. What is the result? Same, no? Minus sign. Differentiate t, sir. So will be 1, bacha. Differentiate t will be 1, sir. And then integrate e power t will be e power t, sir, with dt, and close the bracket. 2 times of t e power t minus e power t. We have, again there will be a plus c for the constant of integration. Takes a 2 e power t common, you'll have t minus 1 plus c, t minus 1 plus c. Okay, what I have, the answer is 2 times of e power sin x bracket sin x minus 1 plus c. This is your final answer. 2 times of e power x or e power sin x times of t minus or sin x minus 1 plus c. Please check. Integration by parts. Okay, using the method of substitution, sir. Substitution is t equal to sin x. Substitution is t equal to sin x. Have a look. This is done. Simple. Okay, let's move on to some more integral using partial fractions, of course. Sorry, particular functions actually. This is the same thing which we have learned this, no? Whenever we have in the numerator a square minus x square in the root, what we do? We simply take 1 by 2x. Same root will repeat. The same root will repeat. A square by 2 sin inverse of x by a. Sin inverse of x by a. We have this form, a square by x square dx. What we do? 1 by 2x, same root will repeat, but this time we'll get log part coming here. Log with this x plus same root. Same thing over here, bacha. When you have negative on this side, same root will repeat with 1 by 2x. This will also remain same, a square by 2. Log with the same thing, x plus x square minus a square. So not much difference is there. You can see it's simple to remember, bacha. The pattern is very simple to remember. Okay. So 1 by 2x and a square by 2 is common. Whenever you have this form, no, 1 minus x square form, only sin inverse will come. In other form, what will happen? You'll have log coming with the same form, x plus same root, x plus same root. Please check. This is my way of remembering it. You don't have derivation of this, okay, but you can do that. Okay, chaliye. Let's move on to the question on this. Can you solve it? Of course you can. 3 minus 2x minus x square. What we can do, sir, first thing is to make the help of make the perfect square with the help of the formula a plus b and a minus b the whole square. So I can see here x square is there, I have 2x also, but with a minus sign I can take it common. 3 is there, take a minus sign common, you'll get 2x. Let's write x square first. Okay, so x square will come first. Next plus 2x, what is missing bacha? Plus 1 square is missing. Minus 1 square will have to be taken out. Reason, sir? I cannot add something extra, no? I have to take it out as well. So I have added, I have to subtract it as well. Okay. I'm getting 3 here minus x plus 1 ka whole square. Then minus 1 as well. So plus 1 here. Of course, we'll have a dx. How come, sir? Minus 1 with this minus sign. This minus 1 with this minus sign will become plus 5. Okay. So I'll end up with 4 minus x plus 1 ka whole square dx, integration of with 2 square minus x plus 1 ka whole square dx. Which form is this bacha? Sin inverse form. A square minus x square. A square minus capital X square. Okay. Format is going to be what, sir? X by 2. So x plus 1 by 2. Okay, you will have the same root repeating. What is the root, bacha? This thing, this whole root, big root. 3 minus 2x minus x square. As I said, same root repeats. Plus a square by 2. So 2 square by 2. What else I have? Sin inverse of x by a. X by a. What is x, sir? X plus 1 by 2. Please check. I can simplify this. So x plus 1 by 2 root of 3 minus 2x plus, okay, minus x square. I have to remove that. I have taken plus sign over here. It will be minus only, no? Same root. Okay. Plus 2 square by 2 is simply, sir, 2 sin inverse of x plus 1 by 2. This is your final answer. Any option like this, please check. Option number A. Option A is correct. Option A is correct. Please check. Option A is right option. This is clear, simple. What is left now? Only one thing is left, so over here with us is definite integral, sir. Definite integral, bacha. Okay, so one of the most important method to solve indefinite integral, okay, is substitution. Of course, we're gonna use this. We have learned it. I wanted to let you know with the what do you call this as well. What I'm trying to say over here is even substitution makes very important in the different integral. So that's why we have taken this part over here. So what are you gonna do now? Very, very important. Look for this will remain same. This remains same. Look for derivative. Derivative is present over here. So then what are you gonna do? Substitute, sir, this as dt. This as dt, sir. Taking this as gx equals to t and dt will be substituted. But that is not enough. What we used to do in indefinite integral, no? This is enough. Start solving the question. Over here, you have to change the limits. You have to change the limit, bacha. Also, limit has to be changed. Okay. We have to find the limits as well. So check this out. When x was t, t will be g of a. Okay. When x was b, bacha, t will be g of b. So I have to substitute, bacha, x as a, t will become g of a. When x is b, t will become g of b. So this whole integration will transform, sir, actually. It will become, bacha, g of a to g of b. Okay. It'll have f of simply t dt. F of t dt. F of gx is there, no? So f of t dt. This part is dt, no? That's why. So you can see the difference in the integration. You have to also change the limits over here. That's very important in the case of a definite integral using substitution method. Either I'll tell you what you can do is solve as indefinite only, do substitution as you do is indefinite, and at the last switch back to the original variable and then put the limits. Or if you're using with the limits, change the limits. Not difficult to do it, but you can choose either method. Okay, so let's move on. Some properties that we have over here. Okay, if we have a to a, what will happen to this, bacha? Let's say integration of fx is going to be, let's say, gx, sir. Let's say integration of fx is, sir, gx. Then this will become, sir, gx from a to a. So what I'll have, bacha? G of a minus g of a. How much is that? 0 only, no? G of a minus g of a is, sir, 0 only, right? Okay, so that's what I'm trying to say here. If you have a case like this, when integration is from the same limit a to a, it will simply come as 0. Okay, when we have a to b, you can interchange the limit. Okay, a to b is over here, you can make it b to a by putting a minus sign in front. Okay, so limits can be interchanged using a negative sign. All right, of course, sir, this is upper limit minus lower limit. This is right now upper limit minus lower limit. I can interchange by taking a minus sign. That's what I'm trying to say over here. Okay, in a indefinite integral, you can change the variable completely. X can be written in terms of t without changing the limits. That's a very beautiful thing. Okay, don't change just x to t and this differentiation like that. I'm not using substitution here. I'm just using change of variable. Change of variable. Very important. Not substitution. Because you will ask me right now, sir, you only said this. If you change this to f of t to let's say f x to t, x to t is not much a substitution actually. X to t is not substitution, it is just simply change of variable. I hope you understand. Okay, so very, very important. I'll write it neatly. Okay, so I'll write it again. Have a look. This is change of variable. Change of variable, and this is not substitution. Very important to know. Not substitution. Okay, very, very important. This property is not substitution, it's only change of variable. Okay, you all agree with me? Chaliye. So property for a to b fx dx can be again broken into more than once. If we have taken away only one, c and c, I can take more than this. I can take c to d and d to b again. If you want, I can take it like this: a to c, c to d, and then d to, let's say, f, and then again f to b. I can break it multiple occasions. Just understand this a and this b has to be the same, and then function you have to check whether what is the function defined in this interval. You've taken in the case of mod, right? If you have the integration between minus a to a, this is very, very important. Minus a to a means negative of the same limit to the value of positive. Okay, what happens is if fx is even function, it comes as twice of 0 to a. If it is even function, no, it comes as twice of 0 to a. If it is odd, it will become 0. So what happens at questions, you'll see they'll give you a very complicated complicated function to integrate from where to where, from minus a to a, and ask you to integrate that. You don't have to actually do it. Why, sir? Why? Because it will be odd function, answer will be 0. That's why please check whether the function is even or not. How you define it? F of minus x is coming as fx means even, coming as minus fx means odd, sir. Okay, just check for this part and then get the answer to be 0. Excuse me. One more thing is there. You can replace x by a plus b minus x. What is a plus b? The limits. Sum of the limits minus x. Sum of the limit minus x you can replace under the same limit. Okay, under the same limit you can do that and answer will not be different. Answer will be same, sir. Okay, so very important properties of different integral. Let's solve one question on it as well. Okay, so find the value of this. Sir, minus a to a is there. It means odd and even can work over here. So for this we'll check later, but for this part we know, we can check it quickly. Let's do it. So if I take, let's say, f of x as a function is ln 1 plus x upon 1 minus x. Okay, let's do one thing. Write this as f of minus x. What will happen to this? It will become ln of 1 minus x upon 1 plus x. Agreed? I can write this as ln of 1 plus x upon 1 minus x to the power minus 1. Okay, this will come in front. It will become minus ln 1 plus x upon 1 minus x, nothing but f of negative of f of x. Check this out. This and this is same, right? So I'm getting f of minus x as same as negative of f of x. I'm getting it as minus of f of x. Okay, it means it is odd, sir. fx is odd. What will happen to this bacha? This part will become equal to 0. This part will be 0, sir. Integration of this part from minus a to will be 0. That is clear. Now we have to look for the other part. What we have? Integrate this minus 1 by 2 to 1 by 2 gif of x dx. Now it's a beautiful function. You know this graph of this minus 1 to minus 1 to 0, actually it becomes bacha minus 1, no, and from 0 to 1, right, it'll become 0, sir. That's how the function is defined. Have a look. I can highlight this. This is my function, okay. This is a close point over here. This also is close point. This is the function, okay. This is the open point, okay. So from 0 to 1, the answer is, the function is giving me 0 value. Any value between minus 1 to 0, answer is going to be minus 1. So I can break this. Minus, I can define this again separately. This will become from where to where, please check. From minus 1 by 2 to 0, bacha. Okay, minus 1 by 2 to 0, sir. It will become bacha what? Minus 1, no? Okay. And from 0 to 1 by 2, what will happen to this? It will become, sir, 0. Okay. So I can define it like this. Please check. Minus 1 from where to where, bacha? Minus 1 by 2 to 0. 1 second, excuse me. Dx plus, okay, this is 0, right? And this will be 0 to 1 by 2, it will become 0. This you can't integrate only. This is gone. What about this going to be? It gets minus will be outside. You're going to get here x, okay. Limits are going to be bacha minus 1 by 2 to 0. Okay, what I'll have, minus sign is outside. I'll get this as 0 minus minus 2, minus 1 by 2 actually. So I'll get this as minus sign of plus 1 by 2. What is the answer, bacha? Minus 1 by 2. What is the answer, sir? Minus 1 by 2. Please go ahead and check it. Answer is option number A. It's an excellent question, bacha. It's an excellent question. Please have a look. I hope you get it. I hope you can see this. Okay, let's have a look. All right, so bacha, this completes our chapter integration. I hope you had fun. If you feel that you have to solve more questions, if you are not satisfied with the number of questions that you have solved, don't worry. I'll solve more questions in the practice session, the live session. Again, if you still want to solve more questions, bacha, what you can do is simply refer my sessions I've given you in KCET series. I've solved almost 100 of questions there in integration. Okay, so I've solved in I think 7 to 8 sessions. Each will have 10 or 12 questions, so almost is 100. If not 180 plus questions has been solved over there. Please go ahead and learn the questions from there. I hope you understand that. So with this session is complete. I'll see you again very soon. Till then, keep working hard, keep smiling. Take care. Bye bye.